10 different ways, 10 different tools that are part of DynoChem that you can use to save time in your everyday chemical development and scale-up projects, and even save time when you're using DynoChem on those projects. So saving time is a key part of the message, and the other part is saving experiments, which is another way of saving time, and also hopefully saving material and so on that would be required to run those experiments. So to try and keep you here until the end of the meeting, we're going to tell you up front about the 10 time savers we're going to feature. So Andrew, will you just animate them in there, please? So we're going to start with properties, then we're going to, so properties of pure components, then we're going to move to mixtures, how you can save time by using our mixtures tools. Then we're going to move to equipment, how you can save time by using the equipment tools. Then we'll combine all of those elements to look at a unit operation, distillation, in a dynamic model, and talk about the time savings that can accrue from that. We'll spend a bit of time in a part of DynoChem called simulator and show you a few time-saving features in there. Then we'll move to chemistry and talk about reactions. We'll show some customer cases. We'll also demo some features that show you some neat ways of accelerating their work. We'll also explore a factor space, so we'll look at situations that we didn't do experiments on and predict how the process would perform under those conditions. Then we'll move into a zone where, now that we have this capability to model, we can do different kinds of experiments. So we'll look at so-called smart experiments, which make better use of the fact that we have the ability to model alongside the experiments. Then we'll move to more of a DynoChem trick, but using the optimization window to find the kind of global optimum best way to run a process. And then finally we'll talk about editing templates. We are going to do all of that in 45 minutes, and that's quite a tall order, so we'll be moving at a pretty high speed. Andrew, can you go to the next one there, please? Thanks. And I suppose we're not going to pause too much during the presentation, because if we did, there's no hope of getting through that material. But the way we're going to do the presentation is, from when we finish this slide here, I'm going to play the role of a new user, somebody working for a customer in process of development and scale up, and I have the usual characteristics that that person might have. I'm skeptical about the use of modeling. I'm busy, I'm in a hurry, all those things that I think you'll all relate quite well to. So I'll be asking Andrew questions, telling him about the work I have to do, and he'll be showing me some of the potential ways in which I can save time using DynoChem. And at the end then of that 40 minutes, we will open the floor to yourselves, the real customers and users, and we'll have a Q&A with yourselves. So from this moment on, I'm going to be a user and a customer, and Andrew is going to be showing us how things work. So I'd like to start in my role as a user by just saying to Andrew, I need to find out the densities and the heat capacities and the viscosities of a number of solvents and mixtures for some scale-up calculations we're doing. I've asked the lab to do the measurements, but they've told me it could take up to a week to get those properties. Is there anything in DynoChem that could save me some time?
Sure, Joe, there is. We have a nice Excel interface really for the DIPA database, which contains physical properties for a lot of solvents. So I'll just show you how you can get that. So the main place to start will be DynoChem resources, which is a good place to start to find a lot of the DynoChem templates. And I haven't really got time to go through it all here, but there is a search box to look for, to search through the templates to find what you want. There is also down at the bottom here, there's some fairly common templates also laid out in groups. So physical properties wise, there's a number here. I'm just going to pick the top one, which is DIPA solvents, which is the solvents from the DIPA database. So to open the file, you'd kind of click the link here. When you hover over the link, it shows you a little preview of what it is, the file name, so you can just see if it's the right one, and you just click on it to open. I've already got it open here, so I'm just going to go to that in Excel, so that would open an Excel template. And basically this utility has a a number of properties that are in the database, so a number of temperature-dependent properties. The ones you mentioned, really, density, heat capacity, viscosity, and several others as well. You can choose the units you want to display it in, and then it also has, then obviously you pick from your list of solvents. So there's a wide range of the most common solvents used in the pharma industry here. You just select one, and you can actually select up to 3, so you can look at mixtures as well. So there's a few other kind of properties reported, like the CAS number, molecular weight, just to check you've got the right solvent, because some of the names can be, you may use a different synonym for the same solvent. So and then down at the bottom it reports results. So here, the table at the bottom, we have density. Full screen here. So you can see density as a function of temperature. You can select the temperature range you want and the units. Also at the bottom, there's a number of other properties, molecular weight, critical properties, etc., that are stored in DIPA. It retrieves all of those in case you need some of those. On the right-hand side, then you have a plot versus temperature of the information, really. So you can see the individual solvents. So methyl isobutyl ketone here is the pink one versus temperature, but also it uses some common mixing rules to get an idea of the mixture property as well. So in addition to the individual solvents, you put in the composition of the solvent mixture, and you can get an idea of the mixture properties as well very quickly.
Excellent, Andrew. That's going to save me a lot of time. That frees up some time actually for me to do some other experiments, so I've got in mind. You see, we need to find out the boiling point of an 80-20 mixture of IPA water, and you can't get that kind of data too easily on the web or elsewhere. So we're going to measure that in the lab.
Okay, well, I don't think there's any need necessarily to do experiments, because that data is actually available, and we have also a tool for looking at that boiling point as a function of composition in DynoChem. So again, going back to DynoChem resources, you can have a look. Actually, in the same area we just looked at, there's one for VLE. It's called VLE and LLE prediction, but if you read the description, it's prediction of boiling points, etc. So again, you click on the link,